In the last session, we have seen the multi-AG of an RDS. So we have done almost all the features of RDS available, but as we have a different database engines available on RDS, in today's session, I want to cover one more database engine just to show you an additional feature which is only available for this Aurora database engine. There is something called a backtrack option, backtrack feature, which is not available on all other database engines. That is only or exclusively available on Aurora. Also, Aurora is having some advanced option, like we can say some additional features. For that reason, I want to cover this Amazon Aurora. Might be not useful for the real time, but in the certification point of view, definitely you might expect a question about the Aurora. 90% that should be from the backtrack feature. For that reason, let's go with Aurora in the today's session. So coming to this Aurora is a RDS database engine which is compatible with MySQL and PostgreSQL databases. What does that mean? Already on RDS, we are having MySQL and PostgreSQL. They are open source, means anybody can take the source code and they can modify it and they can build their own database engines, right? The same way, Amazon Amazon designed this particular Aurora database engine, which works same as either MySQL or a PostgreSQL database engine. Let us say if you have a requirement to create PostgreSQL, first thing you can go for the PostgreSQL database engine, or you can go with Aurora PostgreSQL compatible database engine version. That's purely depends on your requirement. Then the immediate question is going to be, already we have a PostgreSQL or we have a MySQL. Then why should I go with Aurora and I need to choose MySQL compatible, right? That's the most important thing. The reason is Amazon designed this Aurora database engine to provide up to 5 times faster than MySQL performance, 3 times faster than PostgreSQL, and the costs are lower comparatively with the enterprise database versions. So means you will get more performance at low cost. For that reason, you can choose this Aurora. Let us go with few other points also. First, let me write down here. Aurora is a MySQL compatible. That means like it works same as a MySQL, and PostgreSQL compatible, relational database engines that runs on AWS. That runs on AWS. And it is a part of Amazon RDS, but this Aurora is designed by AWS to be faster, more scalable, more available than the normal RDS. So I can say it is designed by AWS to be faster, more scalable, and more available than the normal RDS database engines. And I can say AWS claims up to 5 times faster, I mean better performance than MySQL, up to 3 times faster than PostgreSQL, and costs are lower compared to other DB engines like MySQL. If you choose a native MySQL, if you choose a native PostgreSQL, for enterprise level, then this Aurora will cost you less amount. And here the most important thing is whenever you're having a database, there are two parts. One is the compute part and the second one is the storage part. What does that mean by compute? CPU, RAM, right? There is a compute part and storage. Okay, let me show you in a proper way. So whenever you are having something like this, a database server, whenever you're having a database server, right, in which you are going to have CPU, RAM, storage. On top of that, you are going to install the database software, right? So CPU, RAM, and this database software will be installed on the storage. So they are tightly coupled. But coming to the Amazon Aurora, what they are doing is, so here they are going to have the CPU and RAM, right? And then they will have operating system. And here they are going to install the database software, database engine. Instead of storing the database, let us say here storage is there. Without a storage, there is no what we call that no computer running, right? So here what they do is they are maintaining a shared storage in the network, and these databases are getting created like this. Means the compute and storage are decoupled. What is the advantage? If something went wrong for this physical server, on a different server, they are going to have software running and all, right? Simply, they will attach this storage here and your databases will be up and running in less time. And one more advantage is if everything is getting installed here, whenever you create another database, all the data you have to store in a different server also. Means you are duplicating the data. To store 1 GB of data, it takes like 2 GB of a space. In the Amazon Aurora, the compute and the storage are decoupled, which means they use a shared storage. I will explain that. They use a shared storage. So here, coming to the, let me explain the storage layer and a compute layer, everything. So here, the first thing, Aurora storage and compute are decoupled. Like they have a storage layer and they have a compute layer, right? They have a storage layer and a compute layer on two different instances they are going to run. So what is the advantage is decoupled. That means storage layer and a compute layer are not in the same host. They are spread across multiple things. And whenever we talk about the storage layer, the storage is spread across three availability zones, or in a proper way, I can say 6 copies of the database will be maintained across three availability zones. Means in each availability zone, they will maintain 2 copies of your database backup. Means if 2 availability zones got crashed at a time, your database is highly available and highly accessible. And the Aurora provides auto replicates. It supports auto replicates and auto heals. Auto replicate in the sense the data will be automatically replicated across all the 6 copies so that the backup copies are always up to date. Auto heals in the sense whatever the storage they use, whatever the storage they use, the storage will have a facility called auto healing. Like whenever your machine is not, your system is not up to the mark, what you will do something called disk defragmentation, right? Disk defragmentation, so that it will align the data in a proper way so that you can boost up the performance of your machine. The same way, a normal software level, logical level issues will be automatically healed. and it supports up to 128 terabytes of storage space. It can automatically scale up to 128 terabytes. Auto scaling supports up to 128 terabytes of database storage. And coming to the compute layer, whenever you create the Aurora, I can say Aurora multi-AZ deployment can have one writer node which can handles all the write operations, and up to 15 readable nodes. But what we have seen in the previous database engines, in the multi-AZ DB cluster, you can have one writer and two readers. That's it. But here, you can increase the number of readers as per your requirement up to 15. So that like it is like if you have more read queries, instead of maintaining two read replicas, two readable nodes, you can have uh, five reader nodes, so that the read load will be distributed across all the readers. We can call them as Aurora replicas also. Same way here you will get writer endpoint and reader endpoint, right? So that reader endpoint can be used to distribute all the read loads across all the readers, same as your multi-AZDB cluster. The only thing you have to remember is instead of two reader nodes, you can have 15 reader nodes. Already I said storage is shared by all nodes. No separate storage per instance is required. Main key features of the Aurora is already I said high availability. The data is stored 6 times across 3 availability zones. And most important thing is automatic failover, usually under 30 seconds. Within 30 seconds, the reader will become a writer. By any chance, if there is a problem with actual writer. And in the backend, automatically they will use backups to S3. And it also supports PIT recovery, PIT restore is available here. And also the most important thing, Aurora supports serverless option. Serverless means like no need to choose how many CPUs, how much RAM and all. Just you need to choose how many read capacity and how many write capacity. Automatically it will scales up to like maximum to support your read loads and write loads and all the things. We will see that. We will see that also, like how to do that and all. Okay, right. First thing what we do is the first thing, create an Aurora cluster with a multi-AZ using MySQL compatible mode. We will see serverless and a regular one also, and we will see all the options, all the features, whatever is available on this Aurora at the time of create. Then we will discuss about the backtrack also. So here, logged into our Amazon account. Let me click on Aurora and RDS. And again, remember, Aurora is not a free tier eligible. From the first minute onwards, you will be charged. Click on databases, create a database, same procedure, and I will choose Aurora MySQL compatible. You can see different versions available. Whatever the version you are looking for, you can choose that version. Let me go with some random version that doesn't matters. See, there is no free tier option, only production and dev or test. You can choose anything that doesn't matter. I will say my Aurora cluster, just a name, username admin, password. Now here, cluster storage configuration. We have two different options available for the storage configuration. One is Aurora standard and the second one is Aurora IO optimized. IO stands for input and output operations. So just based on the selection, the storage performance will vary. If your application, whatever the application is using this particular database, if it has very high read or write operations, then it is recommended to go with this one so that the charges will be extra for this particular storage type and you will get the better performance. If you are looking for cost effective pricing, and if you are having just a low to moderate read and write operations, then you can choose this Aurora standard. Simple thing, in the Aurora IO optimized, you can get a 25% more charges than the Aurora standard. Depends on your usage. See here, instance configuration, we have three different options. Memory optimized, burstable instances, which means you are going to choose your number of CPUs, RAM, and all, right? But there is one new option which we haven't seen in the other database engines. Serverless version to see. There is no CPU, there is no RAM. What you have to do, you need to choose minimum capacity and maximum capacity. I will go with minimum capacity as one ACU. ACU stands for Aurora Capacity Units. Maximum, you can go with 256 capacity units. Means this particular database will start with a 2 GB, means you will be charged for 2 GB only. But whenever more number of requests are coming to your database, definitely it requires more capacity units, right? Automatically that one will become 1.5, then 1.5 will become to 2, 2.5, 3, 3.5. Still the load is getting increased. That will increase up to 256 capacity units. Whenever the capacity units got increased, let's say for 1 hour, the capacity units are like a 10 ACU for 1 hour. So the remaining 23 hours in that day, you will be charged for one ACU only, but only for 1 hour, you will be charged for 10 ACUs for effective utilization of resources with less amount of cost. That is possible here. You are saying minimum and maximum. Always your database will start with minimum capacity, and then depending on the load, automatically the capacity will be increased. Then scroll down. You can go with multi-AZ deployment or a normal one also. Let me go with multi-AZ deployment, and all other options are going to be the same. There is no change in that. And this also MySQL compatible edition. So MySQL traffic to be allowed. RDS proxy, right? We will discuss this RDS proxy because it is available for all database engines. You can see RDS proxy is a fully managed, highly available database proxy that improves application scalability, resilience, and security. Okay, let me write down that point here. While the database is getting created, I will explain what that is. Okay, actually, this is going to be the last point before closing the RDS and all. Okay, so now let me scroll down. Additional configuration, database port. You can choose monitoring advanced and standard. Let me go with standard. 7 days that like, you can choose how many days that performance insights to be maintained and all. Monitoring 60 seconds, or you can go with 5 seconds. Logs, you can observe all options are same as the other database engines. Initial database name, I will say myProdDB, some name. And here, just see failover priority, right? And if you see here, no preference, tier 0, tier 1, up to tier 50. Just remember failover priority. I will say no preference, no issue with that. And this is enable backtrack. Let me enable that. I will explain what it is. And here, let me choose a 24. I will explain what exactly this backtrack and all. Let me go with a 2. I will explain this while the database is getting created. I will explain what the backtrack is. Maintenance window, you can choose the maintenance window. Click on create database. Okay, now the database is getting created. What exactly is going to happen here? We have chosen multi-AZ. So initially, what exactly is going to happen here is one cluster will be there. We call it as Aurora cluster. Call it as Aurora cluster, in which you will get a two database created. You will get two databases created. So one is writer and the second one is reader. And here the advantage is in this Aurora cluster, you can create 215 readers. I will say this is going to be the reader 2. While creating, I will give a priority. Let us say tier 2. I created one more. I will say reader 3 and I have given tier 4 and one more. I will say reader 4 and tier 3. As we have given no preference, obviously it is a tier 1 or tier 0, whatever. Okay, right. So here the roles are, this is acting as a writer now. This is a reader, this is a reader, this is a reader, this is the reader. Like you can create up to 15 readers. You can create up to 15 readers. So whenever this writer fails, this reader will become a writer. Whatever the reader instance is having the lowest tier will be having the highest priority to become a writer. And if this reader failed, I mean something happened, then this becomes writer. Whenever this fails, reader 3 won't become a writer. This will become a writer. Why? It is a tier 3 and it is a tier 4. It's a failover priority. Whatever the instance is having the lowest tier will have the highest priority to be act as a writer. This is the, what we call that, a tier, failover priority and all the things. Let me write down that as a point. While creating the readers, we can assign failover priority as tier 0, tier 1, tier 2, etc. Whichever the instance, whichever the reader is having the lowest tier, like tier 0, will have the highest priority to become as a writer in case of a failover. Let us talk about that with an example. Okay, so here we have instances. Instance 1 is acting as a writer. Then we have instance 2 is acting as a reader. We have a failover priority as a tier 1. Instance 3, reader, tier 3. Instance 4, reader, and it is having tier 2. So whenever the instance 1 failed or instance 1 has some issues, then the instance 2 becomes a writer. Why? Instance 2 is having the lowest tier among all other readers. Now, if instance 2 also failed, then instance 4 becomes a writer, as the tier 2 is the lowest tier than tier 4. I think you got the point of like failover priority and all the things, right? Okay. So now what we are going to do is Aurora also supports a feature called back a track. We don't see this feature on any other database engine available on RDS, right? Okay, what exactly this backtrack is? This backtrack is in addition to the point in time recovery. What is the use of a point in time recovery? You can recover your database to a specific point of time. What it does, it will restore a new database using the snapshot of the current database at that particular time. But this backtrack works in a different way. This backtrack works in a different way. So I can say backtrack is an Amazon Aurora MySQL feature that lets you rewind your database. There is a lot of difference between the restore your database and rewind your database. So whenever we restore a database, what exactly is happening? A new database will be created with the exact data at that particular time. Rewind in the sense, your database will be rewind, like it will go back to the point. No new database will be created. Your current database will be rewinded to a previous point within seconds. Rewind your database to a previous point within a seconds. And how it works without restoring the data from snapshots and all. Just we can say it's like undo button. What is undo? You are using a Microsoft Word, you have typed something wrong. Just you can do undo, Control Z, right? It will be go back to the previous stage. The same thing. It is most used. Just you can reverse a bad operation, whatever you have done. You did some wrong delete or wrong update. Instead of restoring the database from the backup, snapshot, and all the things, simply you can use the backtrack. But only thing is, we need to enable this backtrack feature at the time of database creation. At the time of database creation, and need to choose a time window, like from 0 to 72 hours. Okay, again, this backtrack doesn't allow you to rewind your database to like last year or 10 months back or something. It has the ability to rewind your database up to 72 hours. I mean, backtrack has ability to rewind the database up to 72 hours, not every time, up to 72 hours, depends on the backtrack window which we configured on the database. If you recollect, at the time of creating our Aurora database, I have selected 1 hour, right? Means my Aurora database cluster is having a ability to rewind the database up to 1 hour only. Up to 1 hour only. If you want to check, I can show you. If you want to, let's try that backtrack practical also. For that, what I have to do, first I need to connect, right? For that, let me get the writer endpoint. Let me get the MySQL. Okay, where it is? Yeah, here it is. SQL Yoga Community Edition tool. New, I will say Aurora writer, because I'm using the writer endpoint here. Username is admin. I haven't changed. Welcome 123. Click on connect. Yes, I am saving. Here database name is myProdDB. Let me create a table. Student info. Column name is going to be serial number, data type numeric, length some 3, name, variable character, 20 characters, comment, varchar, 500 characters. Let me click on save. I don't want to create more tables. Yeah, one table got created. Yes. Let me create some data. One, name 1, 2, name 2, 3, name 3. Okay. So at what time? What is the time now? It's like 7:06, right? Okay. So here I can say create 6 records of data into the Aurora. What happened? Something went wrong. System got struck. Wait a second. Okay. Into the Aurora database at exactly 7:06 p.m. Okay. Then what we do? Delete 3 records from the database at 7:09 or yeah 7:09 p.m. Then what we can do, use backtrack feature to recover the data by selecting the time 07:08 p.m. Means here database will be rewinded to 07:08 p.m. Means whatever the data exists at 7:08 p.m. that data will be reverted back. Generally, if there is no backtrack feature, what we have to do, we need to use point in time recovery, and we have to choose like 1 minute before the data deletion. The same thing, backtrack allows you to recover the data into the same database instance instead of recreating a new database instance with the required data. That is a simple difference. In the certification exam, definitely if there is a question from the RDS, multi-AZ or data recovery, that should be from the backtrack. There is no doubt in that. Okay. So we have done already 7:08. Let's wait for 1 more minute and then I will execute the delete action. And then we will recover the data to 7:08 p.m. Okay, in the meanwhile, what I do is let me create one more reader. Here, one writer and one reader, right? That's how initially it creates. We can add as many readers as you want. How? Select the cluster, right? You can click on actions, add reader. We use something called a reader 2. Payload priority, you can choose like this. Add reader. Let me create one more reader. But as many readers as you create, the charges will be high. Those many instances are running, right? You will be charged for those many instances. So because we need to check, right? What if the writer instance got deleted? The reader will become a writer. Even if this got deleted, this reader will become a writer. Even if this got deleted, this will become a writer. Even if we delete manually also, the existing readers will become a writer. That is one more advantage with Aurora. Okay. But in the other database engines, we can't delete manually. You have to delete the cluster. Once you delete, everything will be lost. Okay, it's already 7:10. Okay, so let me delete at 7:10. Let us recover the data to 7. Create two more readers, like reader 3 and reader 4. Okay, so here what I do is 5 records. Okay, let me delete 3 records. 1, 3, and 5 I'm going to delete. Yes, and data got deleted. I can refresh. We can see only 2 records. Now I realized, okay, accidentally I deleted the data. Now I want to recover it, right? How to do that? Using the backtrack. We deleted at 710. So if we were able to revert to 79, we can get all the data back. How to do that? Select the database cluster. There is an option called a backtrack here. Instead of restore to point in time, I will choose backtrack and choose the time, today's date, okay, and 17:09 seconds, hours, minutes, seconds. Click on backtrack DB cluster. Let me refresh just to show you the status. What is the status now? Backtracking means your database is getting rewinded to 7:09 p.m. The process might take long, but let me refresh. At few seconds, your database is not accessible, like maximum up to 30 seconds. Still, the data is getting accessible, right? Means the process has been initiated, but not yet started the backtrack procedure. Once it got started, the database might be unavailable for few seconds. Just I'm refreshing. If I get error here means the database is not available. Then immediately the data will be reverted and you will get access to your data. Just I'm continuously refreshing. I got connected to the writer instance, right? I don't want to change the URL. If I delete the writer instance, the reader will become a writer, right? So the new writer is accessible with the same old writer endpoint. Still, the backtracking is in progress. So this refresh is like fetching the latest data from the database. If you refresh the browser, what does that mean? You are not rebooting or you are not doing something the server. Just we are refreshing the connection, fetching the current data, which might take some time, but you will get all the data back. We will verify that. So you have to wait this to be completed. So it is preparing everything in the backend. Once the backtracking procedure has been initiated, the database might not be accessible. Still, it is preparing everything in the backend to initiate the backtrack. That's why the database is accessible here. Once the process is started, immediately the the database will be revived. Maximum time it takes 30 seconds once the process is initiated. And we have to check few other things also, like delete the writer. This reader becomes a writer. Delete this, reader 2 becomes a writer. Delete reader 2, reader 3 will become a writer. That also we will verify before closing the session. And we have to cover the RDS proxy, right? Let me explain RDS proxy, just a theory concept. Somewhere I have written, right? What is this RDS proxy? Highly available database proxy that improves application scalability, resiliency, and security. Okay, first of all, what is the meaning of a proxy? Forget about the definition. If you read the definition as a definition, we can't understand the concept. First of all, what is a proxy? Proxy is like something in front of the actual thing, right? Okay. So here, let us say I'm having my database, right? Here, this is my RDS database, and I have an application running. This is my application. So what the application does, application will establish the connection whenever a user is trying to load some data, right? Amazon.com, Amazon.in online store. The moment I access 10 to 20 images, 10 to 20 products will be displayed on the home page, right? All the information will be loaded from the RDS. What if 1,000 users are accessing? This application will establish 1,000 connections or some more connections to read the data, so that your database will be busy in handling those many requests. Instead, what we can do is we can use RDS proxy. We can use something called RDS proxy. And also, if there is no RDS proxy, application continuously establish a connection. Once the data got received, the connection will be disconnected. Again, a fresh connection, right? It's a continuous process. Here, RDS proxy will establish the connection directly, and application like establishes multiple connections with the RDS proxy. Let us say application is trying to load some image from the database. I want to load an image of iPhone 15 Pro. That request will go to RDS proxy. Already there is a connection, right? Through this connection, it will read the data. So there is a continuous connection. There is no like multiple connections will be established, multiple connections will be disconnected, again reconnected. There is no such kind of mechanism to put unnecessary load on the database. This is what RDS proxy. This is not to improve the read performance. Again, there is a different thing called elastic cache. Don't get confused with elastic cache and RDS proxy. As RDS, there is a RDS proxy. We are not exposing the database directly to the end user. If someone is trying to do something, they can only see RDS proxy. They can't see the RDS database, which is available in the backend. That's how security is available. Scalability, like more number of connections can be handled effectively with the help of RDS proxy. Just you need to know this one. Like at the time of creation, you need to select the checkbox called RDS proxy, and the RDS proxy will be created, and that will be in place to provide service to the application or end users. That is what the RDS proxy. Okay, let us check what happened to the backtrack feature. Still backtracking. Let me refresh the page. Yes. Let me refresh to check the data. See, already we got all the data, 5 records. Now it will finalize the backtrack procedure in the backend, which might take few more minutes to make this status available. See, the same URL hasn't been changed. A new database instance got created. No new database instance, right? In the existing database, I mean, in a layman terms, you can say data will be recovered into the same existing database instance. But technically, we are rewinding the database with the help of backtrack feature. Okay, now what we have to do is delete the current writer instance and observe that one of the readers became a new writer. Then again delete the current writer instance and observe that the reader 2 is the new writer. Then delete the current writer, which is reader 2. Then what happens? You don't have any other instances, right? Any more readers. And observe the cluster got deleted. I mean, observe that there is no readers to be a writer. We will see that. Okay, so here let me check available, right? So what I said first, delete the writer instance, actions, delete, type delete space me, delete. Now the writer is getting deleted, right? Means your data should not be accessible. Let us see. Because even though you click delete, it takes few seconds of time to initiate the delete procedure. Just to show how much time the database is unavailable. Because I said maximum of 30 seconds, the database is might not be available, right? So now what is the time? What is the time? 7:22. Okay. See, within few seconds, the data is accessible because one of the reader becomes a writer within maximum in 30 seconds, a new writer becomes available. See, now I'm getting accessible. Earlier, we got some error because writer is down. The writer is down. So data is not accessible. Immediately, RDS makes a reader as a writer. Let us see. This become a reader. This become a writer. Reader 2 becomes a writer because it has a tier 1 failover priority we have given. There is the lowest thing. Let me delete that also. Delete. Delete me. What is the time now? 7:20. Okay, now we are not supposed to check now. Let me refresh. The current writer is getting deleted, right? Now data is not accessible. You can count seconds. 2, 3, 4. Within 4 seconds, the data got accessible. Means it took like maximum 5 seconds. But they said maximum of 30 seconds, a failover will happen. That is their target. Maximum is 30 seconds. But here we got within 5 seconds the failover done, and we got our data access back. Okay. Now what is this? Okay. Let me refresh and show you. Now reader 3 becomes. Why this doesn't become a writer? Because we haven't given any priority to this, right? At the time of creation. That's why it has the lowest priority. Now, if I delete the reader 3, this becomes a writer. Let me show you. Delete the reader 3. Actions, delete, type delete me, delete. Now this becomes a writer. Even if you want, you can check like this. Refresh. Even I haven't changed the endpoint URL, right? The same URL automatically connects to the instance, whatever is acting as a writer. I think already done. Yeah. What happens if I did the writer? Any guess? If I delete the last instance, Means if there is no readers exist, what exactly is going to happen? If you have a backups, you can recover the data. See what happens? You have only the cluster. There is no databases. I will show you. Once it got deleted, you will not get that data accessible. But you might ask, okay, why we are getting the data? Because still the database is not yet deleted. It is in progress, which takes a few seconds to initiate the actual database deletion. Do you think a new database will be automatically created if you delete the last database? Even you will get answer for that also with these actions. Still the last database not get deleted. Okay, let me refresh the page. Deleting. This is the one. Can you see any new writer instance is getting created automatically? No, not yet. Let me check the data accessibility. Still, we are able to access. Means the writer is not yet deleted completely. Let's wait for a few more minutes. Let us observe that and we can delete this also. Can I add a reader now? There is no writer or reader. Still, can I add a reader? That also will verify the moment once everything got deleted. Or at least we should get some error while accessing the data. Then we can confirm that, okay, there is no databases available. All the databases are unavailable. Just I'm refreshing the page. If you delete the cluster like this, you can't recover the databases. Only using the snapshots, point in time recovery, that is only possible. If you have a like if you delete the cluster means you are deleting the database as you don't need that anymore. Okay, let me refresh to check. Here, everything will take minimum 5 to 10 minutes. Creation procedure, deletion procedure, and all. Especially the multi-AZ, right? Minimum will take 10 minutes of time. Okay, while it is getting deleted, it might take few more minutes. In the meanwhile, if you guys have any questions, just let me know. Just to avoid the naming confusion, one of the reader is the new writer. Delete the current writer. Okay, let me show you. If you want to create a reader like this, actions, add reader, but there is no writer, right? How it works then? Let me show you. Even after deleting all the things, if I click on add reader, what happens is it will create a reader instance. And as there is no writer, this becomes a writer automatic, right? That we will observe. So even after deleting all the database instances, if you have the cluster exist, you can create a new database and you can promote that as a writer. If you delete the cluster, you can't what we call that create the readers, or you can't create the databases under the cluster. So here I will say, after deleting all the databases under cluster, databases under Aurora cluster, create a new reader and observe what going to happen. It will be a new writer. Once everything is done, we will delete the last writer and cluster also to clean. It is getting created, right? See, it becomes a writer now. Becomes a writer. That is the advantage. Even after deleting all the databases, directly you can select the cluster, you can how the reader will be created or how a new database will be created without having a databases. They are maintaining a sequential snapshot like a backups in the backend. From those backups, they will create a new writer instance. Now your writer endpoint URL is pointing to the newly created database, and you can get all the 5 records. Now the actual database got deleted, right? Now no databases exist, and you will get error whenever you're trying to access the database. See, you will get error because the newly created database is also not yet ready. That is in the progress. It might take 5 minutes, right? Till then, the database is not accessible. But once it is ready, you can get all your data back automatically. That's the advantage of Aurora. I mean, even in the other databases also, you can get all your data back, but not this much easy, right? With a few steps, you can get all your data back. That is the advantage of Aurora because it is Amazon's proprietary database engine. But in the backend, they are using MySQL and PostgreSQL only. Okay, right. Any questions? I'm going to delete. Any questions on this Aurora? How come we compare Aurora, especially with the specific, that two different? You can't. I mean, that you can't compare a MySQL with PostgreSQL. If you need a MySQL database, you can create directly a MySQL, or you can create Aurora MySQL compatible. Don't think like same database works as both MySQL and PostgreSQL. If your requirement is a PostgreSQL, you can create by selecting this one, or you can create this one, Aurora PostgreSQL compatible. I mean, Amazon is offering two different database engines under one roof. That's it. If you need a MySQL, you can go Aurora MySQL compatible. It will never act as a PostgreSQL, and this will never act as a MySQL. You can say Aurora MySQL, Aurora PostgreSQL, two different database engines, but they are available under the brand Aurora. That's it. Right. Any other questions? Okay, so if you guys are clear, let us stop the session here. And tomorrow we can cover Dynamo, still database part, not the RDS, DynamoDB and Redshift and Elastic Cache. We can cover these three topics in the tomorrow's session.